Okay, so starting with our first one here, they're going to give us a function. They ask us a three-part question. Graph it, find the inverse algebraically and graphically. Is the original function one-to-one? Step C is the new phrase for us today, but it's not new. We actually already looked at that yesterday. We just didn't use the vocab word one-to-one. So let's start with part A. If they give us this, we are not using our calculators to do this. We're going to be able to graph this by hand and find some pretty points along the way. That's a linear function. You guys know how to graph. That's y equals mx plus b, right? So f of x equals negative 3x plus 5. We would start with the plus 5. That's our y-intercept up here at 0, 5. We have a slope of negative 3. So that means go down 3 to the right 1, or up 3 to the left 1. And that would be my original function. Putting the ordered pairs next to that, not necessary. However, it's really going to help as we get to part B. It says find the inverse algebraically and then graphically. We did this yesterday, right? When it asks us to find our inverse algebraically, it's asking us to switch x and y, and then solve for y. Right? That's what we did yesterday. We just didn't have a picture necessarily to look at once we were doing that. So I go up to my equation. Remember that this is y, where it says f of x. So I switch on my letters. So now it's going to say x equals negative 3y plus 5. Solve for y. You are welcome to leave this as x minus 5 over negative 3. That's totally fine. If you leave it like that, it's probably not going to be super easy for you to graph it from the equation, which is fine because that's probably not the easier method anyway. But you could have rewritten that dividing each one by a negative 3. This would be the same thing as negative 1/3 x plus 5/3. Again, not super easy to graph it in that format. It's much easier to do this method. To do the graphing part of it, what I want you to do is take each of the ordered pairs of our pretty points in the picture. So I highlighted 3 pretty points here. And I'm going to take those nice points, and all I'm going to do is switch my x and y. Okay? And regraph that point. So take this nice point, 1, 2, switch my x, y, 2, 1. Regraph that point. Switch my x and y. 0, 5 becomes 5, 0. Negative 1, 8 becomes 8, negative 1. And those are my new points, and that would be my inverse. Notice the same theme for graphing as it is for our equations. Switch the x and y, right? That's the underlying theme for inverse, is that it switches all of our x's and y's. The last part is what's a little bit new to us, and that is part C. It asks us this question, is it 1-to-1? Okay. Well, guys, I asked you that question yesterday, but I asked you it by saying this. Does it pass the horizontal line test? Okay. That's what 1-to-1 means, is that it passes the horizontal line test. So as we look back at our original picture, that red line up there, does that pass the horizontal line test? Yes. So is this 1-to-1? Yes. Another way of thinking about the topic of 1-to-1 means that its inverse is a function. So when we draw its inverse, when we switch all those pretty points and we have this new picture, the result is also a function. Questions? Okay. Let's look at one more in this same topic here. So your next one says f of x equals x squared minus 3 for x is greater than or equal to 0. So I wouldn't, if you're drawing in pen, I would hold off for just a second here until we kind of get our final picture, because I'm going to erase some stuff as I draw this up here. But you can totally do this one, and this is a good review for us. X squared minus 3, that's one of our parent functions, right? What does the minus 3 do to our graph in this one? Down 3, right? So I'm going to take my favorite points for an x squared, my favorite points being like 0, 0, and I'm going to take 0, 0 and move it down 3. And 1, 1, move it down 3. 1, negative, or negative 1, 1, move it down 3. Negative 2, 4, down 3, 2, 4, down 3. We build that parabola, right? However, they give us this weird thing that we don't normally get, and they restrict with how much of that picture we're actually going to see. And it says that we're only going to look at that picture where x is greater than or equal to 0. So if you look at the x values of each of these dots, or you think about your x-axis where the x's are greater than or equal to 0, it's going to start at your origin and go to the right. So of these dots, this one has an x value of 0, 1, 2. These are negatives. Those are not greater than or equal to 0. So we're only going to see the right half of that parabola. Okay, so that's the function we're starting with here. Questions on just getting that drawn? Okay, so finding the inverse algebraically and graphically. Again, algebraically, we're going to go to our equation, switch our x and y, solve for y. So we'd start out and it would say x equals y squared minus 3, solve for y. Opposite of squaring is square rooting. And I would get the square root of x plus 3. It does have a domain restriction on that one because it's a radical. So anytime one of those shows up in our problem, we identify what that is, and that is that x plus 3 has to be greater than or equal to 0, or x has to be greater than or equal to negative 3. That's the picture, or that's the algebra part of it. Let's look at the picture part of it. Graphically, go to these nice pretty points that we had in our picture. So like 0, negative 3. If I flip-flop those two numbers, I would get the point negative 3, 0. This one would be at 1, negative 2. Flip those 2 points, it'd be negative 2, 1. 2, 1. Flip those 2 points, it'd be 1, 2. And we get this sideways curve. Isn't that look like one of our parent functions, like a square root of x function moved to the left 3? Okay, so again, you can graph from here, or you can graph by flip-flopping your points. I think sometimes it's easier to flip-flop the points, but they should match because they are the same thing, right? So I want to take a second before we answer the last question. Up there at the top, it said x has to be greater than or equal to 0. Does anyone have a guess as to why they randomly threw that into this problem? What do you think? Correct. If they didn't do that, first of all, it wouldn't have an inverse function. We would have to say that it is not one-to-one. But because because it would have looked like a parabola, right? Fails our horizontal line test. Fails our horizontal line test, and moving on down, it said find the inverse algebraically and graphically. Although we could find it, it wouldn't have been a function, which would make our answer to the last part no. But because they restricted our domain on that top part, is the original function one-to-one? Yes. Questions on that? All right. All we're going to do is just take a second and review some that we did yesterday that were just a little bit more tricky algebraically. So see if you remember our steps to finding the algebraic inverse of f of x equals 1 over x minus 3. If you are realizing at this point that you didn't write down the steps as we went through this example yesterday, next to each step I wrote down what it is that we were doing. It's going to be the same. This one's actually a little simpler, so we get to skip one of the steps because it's not needed. But go back to that. Go back to the video or the notes that are online and look at those steps, because it's not going to change. It's going to be the same every time. This is what our problem looks like. And so again, our setup, switch our x's and y's. Okay. When we are dealing with a fraction, step number one is always going to be clear the denominator. So I'm going to start by multiplying both sides by my denominator. Distribute my x through here. And then at this point, we were to move things to different sides of the equation. On one side of the equation, I want to group everything that has a y in it. On the other side of the equation, I want to move everything that does not have a y. Well, we only have one thing that has a y, so anything else I'm going to move to the other side. So I'm going to add that 3x. Okay. This is the step that we get to kind of skip from yesterday. We only have one term that has a y. Yesterday we had to factor out the GCF of a y, but we only have one thing over there. So I just need to finish out by solving for y. Right now it says x times y. The opposite would be to divide by x. And always keeping in the back of my mind, looking for fractions, radicals in the bottom of my fraction. We're looking at a fraction. So my rule for a fraction is that our denominator, which is just x, cannot equal 0. Questions? Okay, and your last one, f of x equals 4th root of 2x minus 9. This is one that I see a lot of steps algebraically out of order. So that's why I picked this one for our last example today. All right, when we are solving this one, the common mistake that I see is people wanting to address the 2 or the -9 too early. We cannot do anything with those. If it is underneath that radical symbol, you cannot address anything that's under there until we get rid of that square root. So after switching my x's and y's, to solve for y, the very first thing I have to do on this one, because there's nothing outside my radical, is get rid of the radical. Do the opposite. The opposite of a 4th root, raising both sides to the 4th, right? 4th root and raising it to the 4th are opposites. And I get an x to the 4th equals, and now I can deal with the 2 and the 9. I cannot get rid of either of those until that is gone. Right? You can't touch anything under the radical until we get rid of the radical. Finish out on this one. Divide by 2. Make sure you divide the entire thing by 2, and you are welcome to just leave it all sitting over 2 or divide each one individually. It doesn't matter. It is a fraction, so we always think about that domain issue, but will our denominator ever be 0? No, because it's the number 2, and it will never change from that. So there is your inverse.